right, now, as I was grading these worksheets, there were several mistakes that I saw that were in common. So I want to first go over a couple of mistakes that I saw several of you making. An example of this mistake is on problem number 16 of the radical worksheet. It says the square root of 45. If I'm taking the square root of 45, can you please give me two numbers multiplied together to give you 45? 9 and 5. Why is 9 and 5 the better thing rather than 15 and 3? Because it's smaller. Because 9 is a perfect square, whereas 15 is not, and neither is 3. Do we understand that? So if we choose 9 and 5, that's going to be our best bets. Now, many of you said the square root of 9 is 3. But what you did is you wrote it as 5 square roots of 3. That's not going to work. Sorry. So, if I have 5 square roots of 3, is that the correct answer there? No, it is not the correct answer. This is wrong. Okay? Now, how do we make sure we do not make that mistake continually? So the way we're going to do that is we're going to tear this thing apart. We're going to make this the square root of 9 times the square root of 5. Now, how do I rewrite 9? 3 what? 3 squared times the square root of 5. Now, what do we know about powers and roots? They cancel each other out. So if they cancel each other out, those are gone, and I'm left with 3 square roots of 5. Did I touch that 5 the entire time? No. After I broke it down into 9 times 5, it stays underneath the radical as a single beam that cannot go away. Why can it not go away? Because there's only 1 underneath the radical. In order for that radical to go away, there has to be 2 underneath there. Do we get that, yes or no?
So if you use 15 to 30, I'll work the same way we get 2 3s.
You'd have to break it down again, yes. You'd have to break 15 down again. Do we all understand that?
Yeah.
Consistent problem that I saw across the algebra 2s. Put that worksheet aside and get out worksheet number 2 for 4-6. Oh, that's 4-5. I think that's for you. Aww. No. Don't read it. The one that I just went over with her. Okay, now, number 1. Somebody please read the worksheet directions. You all could have read it together. Now, if it says to find the x-intercept by completing the square, I have to first complete the square, don't I? Yeah. And then I have to solve for x. Now, you guys have not done this since when? Let's be logical, probably last Monday, if I'm being serious, right? Maybe you did nothing over the weekend. So last Monday was the last time you completed the square on any problem. The reason why that sheet of paper is out because I actually want you to do the problem with me again. Even though you already have it written down, you've already done it, you have a quiz in here tomorrow. If you can't do it today by yourself, do you think you're going to be able to do it tomorrow? Do we all understand this, yes or no? Yes, ma'am. Okay. So number 1, I need to complete the square on this. So step 1, what do I do? Why am I subtracting 12? Because I need to move the constant term over to the other side. Step 2, what do I do?
Make sure x is 1, x squared is 1.
I need my leading coefficient to be a 1. My leading coefficient is the x squared term, and it is in fact a 1. So step 3, what do I do? Sidebar. Sidebar. Very good. Sidebar is correct. So I'm going to go to the sidebar here, and what am I going to do? I'm going to take 10 divided by 2 to give me 5, and I'm going to box that in. Why am I boxing that in? You're going to use it later. Where do I use it? In your perfect binomials in step 5. Do we understand that? Good job, Heidi. Now, what do I do with this? I take 5 and I square it, and that's going to give me 25. Well, what do I do with 25? I take that number and I add it to both sides. Give me 1 minute. Why do I have to add that to both sides? Because what you do to one side, you must have it to the other side. The equal sign is your balancer. Now, go ahead.
Okay. Draw an arrow down from the 10. And you take half of that, so it's 5. And then you take 5 and square it, and you get 25. And you just put it in instead of doing all that sidebar nonsense.
Okay, but that's exactly what we are doing. The only reason I have the sidebar is so nobody gets confused as to where that all came from. If you don't need the sidebar, by all means, you don't have to do that. Many of you are beyond that by now. But some of you still need to write the sidebar because your brain needs to know what you're doing. I totally get that. If you don't need the sidebar, you don't have to. It's just our way of saying this is all thoughts going on in your head while you're doing the problem. You get that? Okay? Now, what do these three terms turn into? Again, we take that sign with this box, and that's going to give me the x plus the 5 quantity squared is equal to, what's negative 12 plus 25? 13. Because if we were to, if I were to factor this into two binomials, x squared turns into x and x. I need a positive and I need a positive here, so that's plus and plus. I need factors of 25 that are going to have to give me 10, right? So that's going to be 5 and 5. Well, how many of those do I have? 2. You can do that every time, or you can just simply remember it. Does that make sense?
Yeah.
What we're doing is we're skipping this step right here every time. So what's the negative 12 plus 25? 13. So now, what was my directions again? To find your x-intercept. So if I'm finding my x-intercept, I have to solve for what? X. So what do I do? I need to take the square root of both sides. And that's x plus 5 is equal to plus or minus the square root of 13. And then what? Subtract 5, and that's going to give me x is equal to negative 5 plus or minus the square root of 13. Now, I have a problem with that. An x-intercept is what on a graph? Point. Are those points? So give me my first point, Dylan.
Negative 5 plus.
Give me my second point, Trevor.
Positive 5 plus.
Negative 5.
It already is negative 5.
It's going to stay negative 5.
Oh yeah, okay, negative 5 minus.
Minus the square root of 13. I'm a 0. Do you understand the difference?
Yeah. Why do you put a 0?
Why do I have to have a 0 there?
Because that's where it crosses the x-axis, so there is no y-coordinate.
Close. By definition, the x-intercept is the point on the graph where it crosses the x-axis. If it's crossing the x-axis, do I have any height or depth on my y-axis? No, which means my y-axis is essentially 0 every time. Does that make sense? So that's why your y-coordinate is always 0. Okay? Now this is number 1. Now let's go ahead and do number 5 together. Number 5 is a little bit more difficult, and the reason why number 5 is a little bit more difficult is what do you notice there?
The 3 and the x.
Because the leading coefficient is what? It is a 3. So since it's a 3, I have to do something special. What do I have to do? I have to not divide by 3.
Factor out 3.
I need to factor out. We're going to talk about the difference here. So I'm going to have 3x squared minus 42x is equal to negative 78. That's the very first thing I have to do, correct? Because I got to take that constant over to the other side. Now, we just talked about getting my leading coefficient to be to being a 1. We talked about dividing, we talked about factoring. What is the difference between those two concepts?
Dividing, you divide everything. Factoring, you don't do it to yourself.
Well, I don't have to divide on the other side either. So technically, would that make it balanced? No. And when you divide, the number goes away forever, doesn't it? When I factor, does that number go away? No, it simplifies it out. So if I factor out my leading coefficient of 3, I'm going to be left with x squared minus 14x is equal to negative 78.
Let's say you use 5 and 3 for 5.
We can what?
5 and 3.
Okay. You can divide both sides by 3. Okay, that's not a bad statement. That's not a wrong statement. But what I want you guys to do is understand what does that 3 represent. If I'm talking about standard form is going to be this right here. What 3 represent in that formula? It's your stretch. As soon as you drop that 3, you now don't know what that thing looks like. Okay? Now, later, are we going to divide by 3? Yes. But I don't want you to do that yet. Okay? So I don't know who helped you, but I would rather them not show you that method, because that's going to confuse you for what we're going to do later. Okay? Now, I want to complete the square on this thing. So what do I need to do at this point?
You need the sidebar.
Sidebar. What am I doing whenever I do the sidebar? I'm going to take 14 divided by 2. Does it matter if it's positive or negative? Because I'm going to have 7 there, and I box that in, and what do I do with that 7?
Square it.
I'm going to square it. Why did I box it in now?
Because you're going to come back to it.
Because I'm going to use it later on in my binomials. So now I have 49. What in the world do I do with 49?
Add it to parentheses.
I'm going to insert that inside of my parentheses. Which means, what am I technically adding to both sides?
3 times negative. Or
Why 3 times 49?
Because it factors when you factor that out, it would be
I need a better one, Kyle. Why am I multiplying by 3 times 49?
so that it's the same on both sides.
That's what Heidi said, but why? I don't disagree, because you do want it to be balanced. What? That's what they both said. Scott?
Because when you distribute the left side, it
The 49 is inside the parentheses. What's attached to the parentheses on the outside?
3.
The 3. How's it attached?
Okay.
So what you're telling me is I'm not just adding 49, but 3 times 49, yes? So I need to tack that on over here also. Do we see that, yes or no?
Yes.
Okay, so now, what do those 3 terms turn into? And what are those 2 binomials? That's going to give me x minus 7 quantity squared is equal to, well, what's 3 times 49? 3 times 50 is 150. 3 times 49 is going to be 3 units less than that, which gives me 147. So what's 147 plus negative 78? 69. So now, Brendan, what do I do? Because I want to find my x-intercept. So I need to solve for x. So what should I do? Divide by 3. But what do I know that 3 to be still? It's still my stretch. Do we understand that? So if I divide by 3, I'm going to have x minus 7 quantity squared is equal to 23. Now what? Take the square root. Many of you are not doing this problem and you're not studying. If I take the square root of 23, can I reduce that? No, that's going to be plus or minus the square root of 23. Now what?
Or add 7.
Add 7 to both sides. Lance, give me my first x-intercept. Carly?
7 plus radical 23, comma 0.
Trish, give me my second intercept.
7. Minus 7 minus the square root of 23.
Lance, do you have a better clue? Does that have anything to do with the fact that you weren't really paying attention to the last example?
Can't write down and listen at the same time.
Okay, turn it over, number 9.
These are the ones that don't.
What are the directions on these?
You're gonna find the vertex.
It says to find the vertex and the A value. Well, what's the A value again? The stretch or your compressed factor. Now, if I want my vertex, that means I'm looking for the up, down, left, right concept, correct? We all understand that. Which means, do I need to solve this thing for x if I'm just looking for the up, down, left, right? No, I don't. All I have to do is get it in the form of this right here. Do we see that? Okay, so how do I go about doing that?
You
can go back to that. What'd you say?
I would say you start off with making the y 0.
I absolutely would start off by making that y turn into a 0. So by doing that, I'm going to go ahead and make this 0 is equal to negative 2x squared plus 2x minus 5. And Trevor cannot stand having that 0 on the left-hand side. It actually, I think, just takes him down to, I can't fix this problem. So what we're going to do is we're simply going to erase this part and make it equal to 0 on the right-hand side. Totally legit. I don't care which side 0 is on. So, with that said, what do I do?
Add 5.
I'm going to add 5. Same exact procedure. Then what? Why am I factoring out?
Because it's only 1.
It's not a 1, so if I factor out a -2, what I'm left with?
I think
X squared
Minus
minus x is equal to 5. Notice how that sign changed. How do I know if I'm right?
two negatives equal positive.
When you say plug it back in, what do you mean by that?
Put the 2. It's still equal to.
So you mean distribute the 2. So if I distribute the 2, -2 times x squared gives me -2x squared. -2 times -x gives me +2x. Is that what I originally had? Yes, so I know I've distributed that correctly, or factored out correctly. Are we good? So now what? Sidebar. So if I'm doing sidebar, what do I do? 1 divided by 2 is still 1/2, so I box that in. I can't do anything with it. Then what? Square it? 1/2. Square it gives me 1/2 times 1/2 to give me what? 1/4. How many people in here are confused that whenever you take a fraction multiplied by a fraction, it gives you a smaller number?
Me.
Is anybody confused about that?
But it's actually bigger.
Is it? Is 1/4 bigger than 1/2?
Oh, no, it's not. Sorry.
It's smaller. Let's
You're
take
taking
cooking.
half of 1/2.
Let's take a cooking.
I meant the number's bigger with it.
He needs to split more.
Okay, I'll get it. Thank you.
He is your kid, right?
Yes. Okay. Now, what you're going to notice here is if I have a candy bar, I want you to think food. We all love food. I have a candy bar, which first of all, first rule is you never share chocolate, right? But let's pretend someone's really super nice.
You can have it on chocolate.
Okay, Scott doesn't like chocolate, so he's going to take his candy bar and he's going to cut it in half. So now he has a whole that now turned into 2 pieces. He gives that to Jamie, but then he still has his half, and I say, well, I want half of your half, right? So now he's going to take that and he's going to put that in half again. Is his part smaller or bigger? Smaller. So whenever I take a fraction and I multiply it by another fraction, I'm going to get a smaller amount every time. Do we see that?
You don't need to divide fraction.
When you divide by fraction, you're actually multiplying by its reciprocal, right? Do we all understand how things can get smaller, yes or no? Okay, now, what am I going to add to both sides? Where am I going to add it to?
Inside the
Inside the parentheses, so I have -2 times x squared minus x plus 1/2, 1/4, sorry, is equal to 5 plus what? Very good, Mackenzie. -2 times 1/4. Outstanding job. Now, what did those 3 terms turn into on the left-hand side there? A perfect binomial. More importantly, what perfect binomial is going to turn into what? -2 times x minus 1/2 squared is equal to. Now let's think about this a minute. What's -2 times a fourth?
negative.
-1/2. So you're telling me that this right here is going to be -1/2. Well, let's talk money. I have $5 and you take 50 cents from me. So how much do you have left? 4.5 or $4.50. Make that into a mixed number.
I don't understand.
That's too big.
Where'd that -2 come from?
Okay.
Like
450
nine.
is the same thing as 4.5. What's 4.5? That's an improper fraction. This is a mixed number.
9.5.
4 times 2 is 8 plus 1 is 9. Just so that we all see that. Is this standard form? Close, isn't it? Close.
Wait, how many? I didn't get the number.
Circle roll. 4 times 2 is 8 plus 1 is 9.
Okay, all right, 4.5. Okay, all right.
Quick question, go up. Where'd that sneaky -2 come from?
This?
That's what you factored out.
Where you crossed the line.
Remember? I didn't add 1/4 to both sides. I added 1/4 times -2. That sneaky little 2 has to stay there. You can't ignore it. Okay? Now I need this to be looking just like this. So how do I make that stuff look like just like this?
Move the Y back.
Subtract the 9 over 2.
I need to bring this 9 over 2 over to the other side. So there's my standard form, and from that, can I get my vertex? So tell me, up, down, left, right, folks.
Down 9/2,
Down 9 over 2,
right 1/2,
right 1/2.
and it's not stretched with the other one.
It is a stretch of 2, and the negative tells me that it's reflected.
Over the what, like that?
Yep. And now, more importantly, what's A? What's A?
Is that right? 1/2.
A is -2, and what's my vertex? Well, right 1/2 it means what? Positive or negative? Right means positive, and down means negative.
I hate this. Hate this. I hate this.
Practice makes perfect.
You said the quiz is.
Uh-huh.
How many questions are
What were my grade up?
There are 8 questions tomorrow. Okay. Now, out of those 8 questions, you have one that looks just like this.
I'm excited.
Tell me how you would solve that. Don't do it. Tell me step by step what you would do.
Are you doing it divide by 7?
You divide by 7. What's the only thing to solve for there?
You changed it.
How many letters do you see there?
1.
1 letter. You have any choices
Are
there.
we doing the vertex?
I said solve. So if I'm solving for x. So what would you do? Divide by 7. That gets rid of that. Then what do you have to get rid of?
Subtract 2.
the square root?
Then you're going to take the square root. That gets rid of the power. Then what do? Then you're going to subtract 2, and that's going to get rid of the 2. Do you all understand that? You see how I'm telling you step by step what to do, and you guys can just do that yourselves? Okay? Okay. How do I find K?
Oh, I can't remember.
Trevor,
Factored in a binomial.
you are absolutely correct. And why are we doing that? Because 49 and 100 are perfect what?
Squares.
Squares. What's the square root of 49? So I'm going to use 7x and 7x. I need 100. Perfect squares of 100. 10 and 10 are both positive. Inner gives me. Outer gives me. To give me. So what's K?
34.
You guys got that. Good job. Good job. Okay, now I do want to draw your attention to this. How do I come up with my C value?
Put it into.
You divide that by 2 and then explain it.
Is it, you just subtract it?
Yeah.
Wait.
Careful, because look, my coefficient's not a 1, is it? My leading coefficient is a 1. You have to manipulate this a little bit by putting this into 2 binomials. 9x squared turned into what?
3x.
3x and 3x. But we are going to take that 60 and divide it by 2 to give me 30. So that says that my inner and my outer must be 30. So how do I get my inner term to be 30? That has to be 10. And my outer? 10. So inner and outer is going to give me 30x and 30x to give me 60x. Is that what I wanted? So what's my last 2 terms multiplied together?
100.
100. Do we see that? Let's do it again. Let's do it again.
I like these ones.
Okay.
6 and 6.
36 is a perfect square.
6x.
So 6x and 6x. And what did I do next? I took the 24 and did what?
Divided by 2.
Divided that by 2 to give me 12. Now I have to have my inner and my outer to give me 12. So what do I multiply 6 by? 12. So that has to go both positions. So last 2 times 2 gives me 4.
Wait, will that only work with perfect squares?
Yes.
I get 2.
Well, you only get.
Well, this takes me divided by 2.
Yeah.
Oh, okay.
Well, I mean, that too.
How did I get this 2?
Yeah.
Because what am I gonna multiply 6 by to get 12?
Oh.
2. So inner gives me 12x, outer gives me 12x to give me the 24x. Is that what I needed up there?
Yeah.
Yes. Oh, this is the easy part. I know, but there's
Then
so much
you
stuff
get
we're doing
4
right
by
now.
adding those 2.
Then not by adding, by multiplying. 2 times 2 is 4. Now, I'm gonna tell you, are we listening?
We're doing the,
Shh. Okay? You have one of these. You have one of these. 2 of these. You have one vertex, one find the value of k, which is this, and then you have 3 completing the square.
what do you mean by the one that you showed us?
Whenever I say solve for x,
No,
Stop it.
the other one, where you said the steps and what you have to do. The ones that you supposed to solve and you couldn't do it, you have to do that one.
we did that here. That's why I didn't take the time. Right here. You guys already didn't have to solve for x. I know you do. Thank you. Okay? Now, tomorrow, since many of you take quizzes at your own leisure and your own pace, I'm not going to have people who get done in 15 minutes have nothing to do. So I have recorded the lesson, 4-8. It is a 12-minute lesson. Since there's no questions being asked, I'm able to give you the material of exactly what you need to do. You can figure it out, write notes, and be done. With me? So tomorrow, you're going to take the quiz as soon as you come in here, grab your calculators, log on. It is an inspired quiz, but I've also put it down on paper so no one has to worry about copying it down correctly. You with me?
Yeah.
After you are done with the quiz, you're going to Control-S, Control-W. You're going to make sure you show all your work on your paper, hand in your paper. Get a laptop at the beginning of the period and have it logged on. Okay? That way you are able to immediately listen to the lecture. That way you have no additional homework tonight. On Thursday in class, I'm actually going to go over the homework with you, and we're going to work together on it. However, I would like many of you to take it home and get a head start on it. Because how many of you have to work Thursday night, but not Wednesday night? And it might help you to get it done sooner. Okay? Now, Friday, how many of you hate Math Excel? I don't care. Every Friday, we're going to have a comprehensive review. Because I need your brains to understand it. Every Friday. Over everything we've done, you guys are going to have a Math Excel assignment. I need your brains to reproduce this and be able to understand it. So, from the beginning of the year to the end of the year. Do you understand me? Yes or no? Okay? Not trying to be mean. I don't want to make anybody feel like they don't understand, but I've given you many opportunities to be able to learn how to do the math. Ask the instructor. I actually recorded some stuff and I put it online to help you out. You can email me. I will help you with that and attach a YouTube video for you to be able to look at it later on. Any questions over that? On Friday, we may have a quick quiz over on 4-8 before you start Math Excel.
What's that I-10 over sin just cause?
I did it, so it was 13.